Okay. So the title of my talk is What is Happening to Pacific Salmon and What We Can Do About It in British Columbia. So buckle up. And here's what you're looking at. This is absolutely mind-boggling. The commercial salmon fishery in British Columbia has completely collapsed. And what you're looking at is the percent of salmon caught commercially in British Columbia in relation to the number of salmon caught in all countries for that year. And what you're looking at is that in 2021, we caught 0.2% of all the salmon caught by all countries. This is a catastrophic collapse of the commercial salmon fishery in British Columbia. And when I give this talk, sometimes I say what's equally alarming is that probably many of you are hearing this for the first time or are seeing this for the first time. And if you look back on this graph and you look at the earlier years, back to 1970-ish, that percent, we were catching 15 to 20% of all the salmon caught by all the countries. And our catches have gone from around 15% of the catches by all countries down to 0.2%. So this is the catch this time just for British Columbia, just since 1970. But this time you're looking at the total weight of all the salmon caught. And if you go back to the 1970s, our catches averaged about 70,000 metric tons. So that was the commercial catch of all species in the 1970s. It increased to almost a little over 100,000 metric tons in the early 1980s. Now look what happened. As you get into the 1995, the catches decrease, and looking over on the far right, you're looking at 2019, 2020, and 2021. And the catches there are, if I remember, somewhere around 7,000 metric tons. Actually, it was 3,000 or 4,000, 7,000. And then in 2021, we caught 2,300 tons. Again, a complete collapse of the commercial fishery. Now you're looking at the total catch of salmon by all countries. The colors represent the various countries. So Canada, Japan, Korea, just almost nothing, then Russia and United States. And this time, the data are going back to 1925. And on the up and down axis over there, that's the number, that's the weight of salmon, all species caught. And so what happens is that around 1995, which is about here, we get a record catch of pretty close to 1 million metric tons. Declines a little bit, and then around 2007, we get historic high catches. So starting about 2007, there are at least 7 years in which the total catch by all countries exceeds 1 million metric tons, beginning around 2007. And then you can see again on the right that the numbers that exceed this 1 million metric tons continue right through to the present. So back to the first slide, which I'm not going to go back to, but in 2021, when we caught 0.2% of all the salmon caught by all countries, there were more salmon in the North Pacific that year than in recorded history. Today, there are more salmon in the ocean today than going back to 1925. At the same time, our commercial fisheries have collapsed. So now I'm going to just show you what the catches are in terms of weight for countries. And this is a very important slide in the next one. This is the commercial catch of salmon in Japan. And in recent years, it's virtually all chum salmon. And if you look at this graph and you look over here, you can see the collapse. This starts around 2005. The commercial chum salmon fishery in Japan has also collapsed. It's now the catches are about 70% less than when they were catching them in around the mid-90s. This is a slide given to me by a Japanese scientist, a colleague of mine. And this time, instead of weight, we're looking at the red bars are the numbers that are caught in the fisheries. The green dots represent the hatchery releases. And Japan, in recent years, produces all of its commercial catch is virtually all produced by hatcheries. And they release almost 2 billion fry into the ocean. And that 2 billion fry represents about 40% of all salmon raised in all hatcheries by all countries. So it's a large number. What's really important here is that as that commercial fishery was collapsing, which I showed you in the previous slide, and as you can see here, the hatchery releases are about the same. There's a slight decline. So the decline in catch of 70% is unrelated to the number of chum fry that enter the ocean. As I said, there's a small decrease in the hatchery releases, but in general, it's unrelated. A 70% decline in commercial catch of chum salmon with very little reduction in the number. Absolutely crystal clear, the reason for the decline is something is changing in the ocean. This is the catch of all salmon in Russia. And looking over here again, about 2005, and the bars show you that the commercial catch is increasing. The axis over there, about the middle, is about 500,000 metric tons, so a lot of fish. And a couple of years when it exceeds almost 700,000 metric tons. So Russia's catches are increasing dramatically as the catches in British Columbia and Japan are collapsing. And this is the commercial catch of all salmon in Alaska. Same thing. The Alaska catches, total catches, are increasing in the last few years, last decade or so. They are increasing along with the Russian catches and along with decreases in Japan and British Columbia. So this is what's happening to salmon. The capacity of the ocean, which we call carrying capacity, the capacity of the ocean to produce salmon is declining in the southern areas of their distribution and increasing in the northern areas of their distribution because of climate. Climate is changing the capacity of the ocean to produce salmon, changing it in a way that there are more salmon in the ocean now than in our recorded history, but with the declines towards the south. So now I'm going to look at salmon species within British Columbia. Sorry, I will look at that, but I want to, first of all, look at, when I said it's climate, I'm going to show you some of the major factors that relate to the climate effects. And I'm pretty sure that most of you have never seen this before. And what you're looking at here is what we call a regime shift. A regime shift is a natural change in the climate that occurs very quickly. And it can have massive impacts on the ocean capability of producing salmon. I guarantee that what you're looking at here, there'll be no scientists that will. There might be some. There's always people that disagree with everything, right? So forget those guys. Most scientists will agree with what I'm going to tell you here. So what happens in 1977, there's an abrupt change in our climate that affects the change in the ocean ecosystems. And in the Bering Sea changes from an ocean that is mostly producing shrimp and shellfish, and it changes to an ocean ecosystem that produces salmon, halibut, Pacific cod, walleye pollock, and some other species. Alaska will take credit for all of the abundances that increased into the 80s, 90s, and the present for good management. They do have good management. The increases are entirely related to this abrupt change. So this is a change that happened in 1977. There really is no scientific understanding of what changed this. But there are other changes that occurred around 1989, another one around 1998, I think one around 2007. These are similar changes, but not as large scale, and those changes cause abrupt increases and decreases in species abundance. So this is one climate-related change that we cannot explain scientifically, but it occurs and it causes abrupt changes. This is another change. This is another climate-related change. And this is something that people have heard more about. It has a nickname called the blob. And this is an ocean warming event. In general, this is a unique event. I don't think that we have seen an ocean warming event in our science history for the Gulf of Alaska, which is over there. And when this starts, this first one occurred around 2014, and you can see that this is a massive amount of warming. And it basically lasts to maybe the end of 2017, and then it appears again in 2019. So we have no scientific explanation for this, but this warming has significant impacts on the overall way that the ecosystems work and on salmon. We don't have a scientific explanation why this occurred, but I'm going to tell you that I think it occurred because of a weakening of the winds in the winter over the North Pacific. And as those, we call that the Aleutian low pressure, maybe some of you know that. And if those winds become less stormy, you get less cool water coming sucked up from the deep water. And that cold water then is not circulated into the coastal areas in the spring. And a consequent, the warmth in the water that was there in the summer isn't cooled. Now that's just Dick Beamish's explanation. There are some other people. But you can see if that explanation happened to be correct, again, this is a major climate effect, something that hasn't occurred before. And then one more. This is again an indisputable consequence of our changing climate. And we know, now this is an average, and then you take measurements from an average. And the average goes from 1960 over here to about 2020. And so this is just the differences from that average. But beginning around 1995, oceans start to warm. So the global warming scenario that I think most of us accept now, 90% of that heat that's produced in the ocean or in the atmosphere is absorbed by the oceans. And as a consequence, the warming of our atmosphere ends up warming the ocean. And the warming for the North Pacific looks like this. And the warming goes down to very deep. This is a first 300 or 700 meters, something like that, but it can go down to a couple of thousand meters. And probably, but I think almost certainly, the reason that we're seeing the very high catches of salmon in Russia and in Alaska is because of this warming that's going on. This warming is good for food production in the northern areas of salmon distribution. So these are three major climate-related changes that occur to the ocean ecosystems that affect salmon. Now, we're going to look at what's going on with salmon in British Columbia. I'm going to start just by showing you, this is the sockeye returns to Alaska, Bristol Bay, and the Fraser River. And that goes back to 1998, and this is to the present. And again, you're looking at an average and the changes in returns relative to that average. And at the top is Fraser River, and the bottom is Bristol Bay or Alaska. And again, very clearly, the opposite direction. So as the sockeye returns are declining to the Fraser River, sockeye returns to Bristol Bay and Alaska are increasing. The mechanisms, the causes of the increases and the decreases will be the same. Now we're going to look at sockeye a little more detail. This is fun. Wait till you see this. So this is the graph of sockeye salmon returning to the Fraser River. Probably many people have seen this before. Going back to 1950, increasing to the early 1990s, and they with the 4-year cycles. And then in 2009, right here, we get a very poor, unexpected return of 900,000 fish. And that so alarms our prime minister at the time, if you remember, I think it was Harper, that he asked Judge Cohen to have a Cohen Commission. And I'll talk about that in the next slide. But what happens after the Cohen Commission is that in 2019, the return is, I think, 700,000. Sorry, I got it wrong. 7,000, 9,000 here, and then 7,000, worse than 2009, without anybody paying any attention. And then 2020, I think it might even have been 3,000 or 4,000, something like that. So again, worse returns than the return that started the Cohen Commission without anybody even talking about it. So, and then this was a record return in 2010, which the Cohen Commission paid no attention to. 2009, 900,000, right? I always get my numbers mixed up. Record return, and then 2 very poor returns there. So, this is what the judge said. I'm going to read it to you, the first couple. That's right. The judge says, I'm also satisfied that marine conditions in both the Strait of Georgia and Queen Charlotte Sound in 2007 were likely to be the primary factors responsible for the poor returns in 2009. This is what the judge said. Marine conditions, that's the same as climate. He just didn't use the word climate. So the judge said the poor returns in 2009 are a result of climate. He wrote that. But this is what everybody heard. The judge also said, some, I suspect, hoped that our work would find the smoking gun, a single cause that explained the 2-decade decline in productivity. The idea that a single event or stressor is responsible for the 1992 to 2009 decline and the Fraser River sockeye is appealing but improbable. The smoking gun is, where am I? There. The smoking gun is right here. The smoking gun was very clear, but nobody would believe that climate was important at the time. They were looking for a perpetrator. They were looking for someone that had that gun and did something. And because they were looking for that, they concluded that they couldn't identify what it was. The judge identified it, wrote it right there. The decline in 2009, as well as a recent decline, are entirely a consequence of changing climate. Now I'm going to show you some more evidence for saying it's entirely related to climate. So what you're looking at here is the otolith. This is a bone in the head of a sockeye. And those lines are spaces. And those spaces are deposited on that structure daily. And you can measure the width of those spaces, and you can calculate the size of the fish at the time those spaces were formed. So a lady named Lise Godbout, up at the top, and she did this study and has never published it. It's a beautiful study, and she has given me permission to talk about it. And I think I'm the only one she gave permission to. So I talk about it. So here's what this shows you. Now, this was not done at the time of the Cohen Commission, so that this was done after. So over here where it says daily growth, you can see that, okay? And then where it says 2009 and 2010. The 2009 actually represents the size or the growth of the juvenile Fraser River sockeye when they were in the Strait of Georgia in 2007. And then in the 2010, that's when they were in the Strait of Georgia in 2010. And what the numbers show you is that right here and right there, in 2007, the fish grew very poorly. And in 2008, they grew much better. The fish that grew very poorly had a very poor survival. Her estimate of survival, total survival, was 0.4%. And the ones that grew very rapidly had a survival of almost 7%. Absolutely crystal clear that the fish that came back in 2009 that resulted in a very poor return grew very poorly, and the judge just got through telling everybody they grew poorly because of poor climate, which was poor food production. Now, this is some data that I published 30 years ago, and I haven't presented this in a long time, but for this presentation, it's very relevant. So let me explain what this is. This is 37 years of data. These are data collected by the Salmon Commission staff. And when sockeye come back and spawn in the Fraser River, so these are successful fish that have lived in the ocean and come back to spawn. They collect the scales, and when they look at the scale of the fish, they can identify the size of the fish at its first ocean residence, its first year in the ocean. And what you're looking at here is the size of salmon at their first ocean year, their first ocean winter. And each dot represents 100 fish. So 37 years, 100 fish, the average size, it's all the same. There's one difference, and that's 1977. And I've already told you that 1977 was a unique year. So forget that. So back to what you're seeing there. That is showing you that only the largest of the Fraser River sockeye are able to survive their first ocean winter. This is going to be jaw-dropping. I have a bet going on with this right over here. Not this slide, it's the next slide. So here you're looking at Copper River sockeye. And you may know that Copper River sockeye in Alaska are the first sockeye to return to the river. They sell in the Seattle market for about $40 US a pound. So they are a sought-after species. They are the first of the season. They are esteemed in terms of their value. And now you're looking at, this is not my slide. This is a slide of a scientist that was produced at a recent conference. But look at this is the length of them over here, and there's the decline. This is 2021. The decline in size is remarkable. But look at this. So you are the first group to see this. No scientist, no one has ever seen this. This is a slide that I put together. Now, I didn't do it. I can't do PowerPoint very well, so my daughter did this, but that's okay. And what you're looking at, the blue is what I just showed you, Copper River. The red is Fraser River. The Fraser River sockeye are declining identical to that catastrophic decline in Copper River. And I don't think there's anyone in the Salmon Commission that has ever said this. We use their data. But what this means, well, the decline is huge. And this obviously because Alaska sockeye and Fraser River sockeye are showing the same decline. That is a consequence of what's happening in the ocean. And what that also means is as these fish decline in size, if you're a female, you're producing a lot fewer eggs. And that's relevant. If any of you are going to the Salmon Commission meetings, tell them this, all right? Because it's not just numbers returning now, it's actually how many eggs are being produced by the numbers that are coming back. What you're seeing there has never been seen by anybody before other than my daughter, who helped me produce this. Now, the next one is fun. So at the end of this talk, I'm going to conclude that we need to know a lot more about Pacific salmon. And here, what you're looking at is I organize privately funded studies of the ocean life, the ocean ecology in the winter of salmon. And they cost about $1.2 million. And in 2019, I chartered a very famous Russian research ship. And these are data that they collected. And these red dots are Canadian sockeye in their first ocean year. These are data that have never existed scientifically before. This is the first time anyone has produced these data. Now, other people have seen them, but so this is the first time that we've been able to say where sockeye salmon from British Columbia are in the ocean in their first ocean year. We tended to, if you look over there, the belief was that they would come out of rivers, go up along the coast of BC, along the Aleutian Islands, make a U-turn, and stay in the Gulf of Alaska for their first winter. So if you wanted to study them, you looked at ocean conditions and things in the Gulf of Alaska. But look over there. That's the first discovery of Fraser River. Well, it's Chilko Lake, way over here, west of 180 degrees. No one has ever been able to show that our sockeye in their first ocean year are that far west. You have to be in pretty good shape if you're a juvenile sockeye salmon, first of all, to get all the way over there. And you have to be in even better shape to get back to spawn. So that's new information just because we're starting to take a look at trying to understand what's going on in the ocean. Okay, I'm going to switch to a few other species. This is chum salmon. And it's very difficult for me, anyhow. It could be my problem. It's very difficult to get good information about chum salmon. These are the commercial catches in British Columbia, and I just put them in 20-year intervals. So from 1950 to about 1990, the catches are about the same. Probably many of you know this. And then 1990 to 2009, there's a decline. But look at 2010 to 2021. Hang on. So a major decline. But now look at this. This is what I started talking about. 2019 to 2021. That's the average catch of commercial catch of chum salmon. Chum salmon by weight, not by value, but by weight, are the most important salmon in our commercial fishery. It has completely collapsed. I can't identify anyone that's studying this problem. Now, the next slide, I call $1 million slide. This is absolutely remarkable stuff. This is a survey that we did last year. Again, a privately financed. I raised about 1.3 million. And I have a colleague named Chris Neville, who was a chief scientist. And last year, we used Japanese experimental gill nets to study the ecology of salmon in the Gulf of Alaska. And what you're looking at is a gillnet catch. And there are 7 chum salmon there, all in their first ocean winter. And those 7 chum salmon come from northern British Columbia up into the Gulf of Alaska. So we look at the DNA. By looking at the DNA, we find out where they came from. Those chum salmon have come out of their rivers into the coastal area, and they have said to themselves, I got to get into a school by winter. Not only that, all the chum salmon had to emit an odor or pheromone that was specific to chum salmon. And then they had to detect that odor in a vast area of the ocean and then swim towards where it was more concentrated and then get into a school and say, finally, we're all together in a school. It sounds impossible. The reverse is what we've already known in terms of them coming back to the rivers where they spawn. All I'm saying is we're now discovering that they can do this in the ocean for their first ocean winter. And you can imagine if this is common, what it means in terms of understanding how climate affects these fish in their winter. Oh, just a couple more slides. I thought I would look at coho. And here I'm just comparing the commercial and sports catch of coho in Canada and United States going back to 1950. Now, I know most of you know this, but here's a decline starting in the late 1990s, the commercial and sports catch of coho. It's a massive reduction. Much of this reduction is from management. So because coho abundances were declining, particularly in the upper Fraser River, the management decision was we need to stop the fishing so more fish can spawn. That would produce more babies, more juveniles. They would come into the ocean, and gradually that ocean abundance would increase to the previous levels, and we could start fishing again, except that we never did. Now, I'm going to show, I only have time for one slide, but this is from the Strait of Georgia. We have published this. I have a paper that I could give you about this. And so the axis over there that says CPUE, it simply means abundance. And we have been doing surveys in the Strait of Georgia for 20 years. And in September, we estimate the abundance of juvenile coho. Okay, that's clear. And that's the abundance here. And then abruptly, around 2007, 2008, abruptly, all of a sudden, the abundance increases. And the abundance continues to increase. So again, there's no question about that. A colleague at the same time is looking at plankton in the Strait of Georgia and shows that at the same time, there's a huge increase in plankton production or the food for coho salmon. So this abundance increase is related to food. We have the evidence for that. But here's what happens. That abundance increase occurs, I don't have the time to show you all the data for it, but it's published. We know how many fish are escaping. In other words, how many juveniles are produced that go into the strait. Go back to what I showed you for Japan, where they know how many enter the ocean. We know that. So there's no increase in escapement that produces this. But even more important is that if those of you that know Mel Shang around 2003 starts to reduce the number of coho released from hatcheries around the Strait of Georgia. And over this period of time, he reduces the number that are released by 70%. So over the period that these are increasing, there's no increase in spawning, and there's a major decline in the number of hatchery fish that are released. This is entirely related to climate-related changes in the Strait of Georgia. And then just one more slide, just for the steelhead fans. This is from last year, where we're using gill nets. No one has done this before. This is the first time anybody has gone out in the winter in the Gulf of Alaska to study steelhead since 1960s. Some of you, if you were out in 1960s, okay, but no one has done this. No one has even attempted to study steelhead in the ocean. This is the first attempt to study steelhead in the ocean. In our catches last year, we're using Japanese experimental gill nets. We catch more steelhead than any other species. But this is what's absolutely remarkable. These steelhead are caught in the top few meters of the ocean. So I'm telling you that steelhead use the ocean completely different than all other salmon. Steelhead use the ocean. They're out there for 2 or 3 years, or maybe even more. For that entire period that they're out there, they are using the ocean completely differently than every other species of salmon. Not only that, you can see that they would be far more susceptible to climate changes at the surface of the ocean. No one has said what I just said. No biologist has ever said that steelhead are confined to the top few meters of the ocean for their entire ocean life. So you have two choices. Either what I just said is what, right? I won't use the word BS, or you have to start thinking differently. So this is a conclusion. You need to recognize, we all need to recognize that there's a lot more to learn about Pacific salmon. We need to recognize that we really do not understand why salmon populations have collapsed in British Columbia. And if you believe that, you need to recognize that you cannot fix what you don't understand. This is really important. This says that salmon have always been resilient, always been able to adapt to ocean habitat changes for hundreds of thousands of years. So within the genetic ability of hundreds of thousands of populations, each one had a slightly different ability to survive in the ocean. And as the ocean changed, some would do better and some wouldn't do better. But even the ones that didn't do better didn't become extinct. They just became less abundant. So there is still some what we call resilience left if we were to understand what it means and capitalize on what is left. And I think there are opportunities. And then my final comment is that we need to work as teams. We not only teamwork in terms of within British Columbia, but internationally. All around the Pacific, we have researchers trying to understand the same thing, and we need to work together. And what the science that I think needs to be done is what I call whole life cycle studies. And that is studying salmon right from the spawning to residence in the gravel, to leaving the gravel, to downstream, coastal ocean, open ocean, returning. And I'm proposing that you have probably 3 teams to do that. And that's a completely different way of doing salmon research. And that's my talk.